Good afternoon, class. Here's chapter 5, integrals, sections 5.1 to 5.3, the fundamental theorem of calculus, or short FTC. FTC has two parts. d dx of the integral of a to x f of t dt equals f of x, meaning if you integrate a function from any number to x and differentiate it, you get the function at x, f of x. Also, the integral of a to b f of x dx is capital F of b minus f of a, and of course, capital F prime is lowercase f. In this case, we are coming up with a number. This is called a definite integral, and it represents an area under a curve if the function is positive, otherwise it's difference of areas. So we want to evaluate this. Obviously, it's a very simple anti-differentiation. This is 5 thirds x cubed minus 2x squared plus 2x, and we are going to evaluate from number 2 to 0. So we plug in 2, we plug in 0, and we look at their difference according to FTC. So having said that, clearly when we plug in 0, we get 0. But what happens when we plug in 2? 8 times 5 is 40 thirds minus 8 plus 4. This is minus 4 or minus 12 thirds. They add up to 28 thirds. That is the final answer. What about this one? We make up two fractions. This is elementary algebra. We get 4v cubed minus 3. And now this is the only calculus step. 4 divided by 4, v to the power of 4 minus 3v, or simply v to the power of 4 minus 3v. This is the only calculus step. We're going to plug in 2 and then 1 to evaluate them. (16 minus 6 is 10. 1 minus 3 is negative 2. 10 minus negative 2 is positive 12. The integral of 1 to 3, x squared minus 7x plus 2 over x squared. You may recall that we did this as an indefinite integral, but now we are doing the same thing as a definite integral. We make up 1, 2, and 3 fractions. The first one is 1. The next one is minus 7 over x, and the last one is 2 over x squared. To make sure we can integrate this, I'm going to remind you what we did last time. So we're going to write this as minus 7 times 1 over x, and we're going to write this as 2 x to the power of minus 2. This one, because this is dx, becomes x. This one minus 7 natural log of x, and this one is 2 over negative 2 plus 1 x to the power of negative 2 plus 1. 2 over negative 1 becomes minus 2. X to the power of negative 1 goes down, becomes minus 2 over x. We're going to evaluate it from the lower limit 1 to upper limit 3. And so let's plug in. 3 minus 7 ln 3 minus 2 thirds minus 1 minus 7 ln 1 minus 2. Obviously, ln 1 is 0, so is minus 7 ln 1. So 1 minus 2 makes it negative 1. And this makes it positive 1. And we repeat the first brackets unchanged. Because we want to add the three numbers, because we want to come up with the exact answer, we notice this is a fraction. So with denominator 3, we're going to change this to 3 thirds. And this one to 9 thirds. 9 and 3, 12 minus 2 is 10. 10 thirds minus 7 ln 3 is an exact answer. So we keep it as an exact answer, everybody. Again, we're going to look at questions that have been already done. We had indefinite integral. Indefinite meaning the result is something plus a constant. Definite means we have a number. So I hope you remember, because this is t, that dt. That gives us t, that gives us sine. Remember, the derivative of cosine is negative sine, but the integral is positive. We're going to plug in the limits. Obviously, this goes to 0 because sine of 0 is 0. So pi over 2 plus sine of pi over 2 is 1. And again, we have an exact answer. The integral of 1 to 4, 5x squared of x plus 3 squared of x. And we have to change square root of x to the power of 1/2, so we can combine these two into x to the power of 3/2. So we have 5x to the power of 3/2 plus 3x to the power of 1/2, which makes it ready for the next step using the power rule to integrate. So having said that, this is 5 over 3/2 plus 1x to the power of 3/2 plus 1. Plus, this one is 3 over 1/2 plus 1, x to the power of 1/2 plus 1. 3/2 plus 1 is 5/2. This is 2. 1/2 plus 1 is 3/2. This is also 2. Let's plug in 4. Let's plug in 1. Again, please understand there's only one step of calculus right here. This was algebra. This was algebra. This is algebra now. And this is algebra. We're going to plug in and evaluate. So first and foremost, this is 1, so this entire thing is 4. But what about the rest? 4 to the power of 5/2 is square root of 4, which is 2 to the power of 5, which is 32, times 2 is 64. 4 to the power of 3/2 square root of 4 cubed, which is 8, times 2 is 16. 64 plus 16 minus 4 is 76. Water flows from the bottom of a storage tank at a rate of R of t equals 200 minus 40 liters per minute. Find the amount of water that flows from the tank during the first 10 minutes. So we are given the rate, the derivative function. So if this is the derivative of a function, then we let capital R of t represent the amount of water that flows from the tank at time t. Then the rate of flow becomes the derivative of this R prime, capital R prime, which is lowercase r of t, 200 minus 40. So the amount of water follows what we call an accumulated change. Therefore, the amount of water that flows from the tank follows the integral of a to b f of x dx, capital F of b minus f of a, which is also known as the accumulated change or net change theorem. We are interested in this for the first 10 minutes. So the integral of a to b f of x dx becomes the integral of 0 to 10, 200 minus 4t dt. This is 200t. This is minus 2t squared. We plug in 10. We plug in 0. 0 obviously gives you 0. Let's plug in 10. 2000 minus 200 is 1800. We go back to this one, says liters per minute for the rate. So this must be in liters. Example 8, many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? I'm going to go with 1 decimal. Well, again, growth rate. This is the derivative of some function. So if this represents the derivative, the growth rate, then L of x or something like f of x, we can use to represent the length because this is the growth rate. So if L of x represents the length of fish at age x, then the growth rate L prime or dl dx must be this 29 e to the power minus x. And what is this one? The initial value, L of 0 equals 1 centimeter. So this is explaining the entire situation. And so if we want to go with the accumulated change, the amount of increase over the course of the first 4 years is the integral of this, of course, times dx from 0 to 4. And so when you integrate this, it just becomes negative 29 e to the power minus x from 0 to 4. If we plug in 4, if we plug in 0, we can take out the common factor of negative 29 and say e to the power of negative 4 minus e to the power of minus 0 over 0. This is 1, but you have to put this into a calculator. If we do so, we end up with 28.4688. Now, this is the amount of increase over the course of 4 years, but it started at 1 centimeter. We need to add 1 centimeter. And because we want 1 decimal, 4 next to it is 6, go up to 5. We're done with that. But I want to show you a second method. That means if we find L of x in general, that means we want to integrate this without the limits. We already have the answer. We just add a constant. So this one, add a constant with this initial value. Remember, this is a general solution, everybody. And this will help us find one of those. So plug in. And C becomes 30. Now we want what? L of 4. If I plug in 4, I get exactly the same answer. Now, what is the advantage of that? The advantage of this is if they ask for different parts, part B, how long will the fish be after 5 years, plug in 5, after 7 years, plug in 7, and so on. So that's the advantage. Otherwise, this works just as good.